Let's go on in section 2.2. We're talking about circles, and the big idea so far is that if we want to write the equation of a circle, we can do that with center radius form. And so let's write that out here. Center radius form says x minus h quantity squared plus y minus k quantity squared equals r squared. Gives the formula for a circle with center at h comma k. And radius r. And so in example 3 here, we've got some formulas for some circles, and we want to find the center and the radius for each one. And so if we look at this first example, we have x plus 5 squared plus y minus 1 squared equals 4. And so the first thing to notice is that this is center radius form. And so we should just be able to pull off the values of h and k and r pretty quickly and get our answer. Now, you might want to be, just in this first example, you might want to be just a little bit careful about what we're doing. So maybe, in the formula it says x minus, and then in the example we have x plus 5. So we could write that as x minus negative 5 so that it fits the form of the formula. And then y minus k, well, we have y minus 1. And then we want r squared. So what number do you square to make 4? That would be 2. And so now if we write it out like this, then hopefully we feel pretty good that h is negative 5 and y is positive 1. I'm sorry, not y, but rather k, the y value of the y coordinate of the center. We're calling it k, and that is going to be a positive 1, and then the radius is 2. So center at negative 5, 1, and radius equal to 2. And so we probably don't need to write this step out every time. Probably what we need to do is just look at the equation that we are given here, and just take the opposite sign for h and k, right? So if we have x plus 5, then that means we need a minus 5. If we have y minus 1, that means we need a positive 1. And then over on the other side, we're just going to take the square root of this number, this 4, and that'll tell us that the radius is 2. Okay, so that looks good. The next example maybe is just a little different. Looks like maybe there's no h or k at all. Can you see what we're going to do about that? I guess we'll write it out again. We'll write x minus 0 squared plus y minus 0 squared is equal to 1 squared is the same as 1. So of course what we've just written out is equivalent to the formula we were given in the problem, and we can see that the value of h and k must both be 0. So the center is at 0, 0, and the radius is equal to 1. And this is actually a special circle. This is called the unit circle. And if you go on to trigonometry next semester, you'll study the unit circle quite a bit. Okay, so let's go on to the next one. And oh wow, so now this one looks different still. This is not in center radius form. Do you remember the name for this form? This is called general form. And so if we want to find the center and the radius of this circle, then we need to convert the equation from general form to center radius form. So convert to center radius form. And so how will we do that? It's actually something that we did in chapter 1. If you think back to it, it'll look familiar when we do it here in a minute. What we're going to do is we're going to complete the square on x and y here in this equation. So complete the square. And so let's go ahead and group the x terms together. Let's do x squared plus 8x. And then let's do plus y squared minus 6y. And then let's just go ahead and kick that 24 over to the other side. It won't help us. And it won't help us to complete the square. So we don't need it there on the left. So notice also I left a little room between the 8x and the y squared. I also left a little room between the minus 6y and the equal sign. That's so that we can just go ahead and complete the square right here. So what we said in chapter 1 is that if you want to complete the square here, you've got an x squared and then an x to the first, and then we're going to add on a special number so that when we factor this thing, we get a perfect square. We get something multiplied by itself, which of course is exactly what we need for center radius form. So we're going to take this 8 right here, and we're going to come out to the side, and we're going to take half of 8 is equal to 4, and then 4 squared is 16. And so this 16 tells us that we need to add 16 to complete the square on x. And then we're going to do the same thing with y. We're going to look at the coefficient on y, the negative 6. We're going to come out to the side. We're going to take half of negative 6 is negative 3. And then we're going to square the negative 3 and get a positive 9. And so we're going to add 9 to complete the square on y. And then we can do that. That's fine as long as we add the 16 and the 9 to the other side as well. Plus 16 plus 9. And then maybe I'll just clean that up just a little bit there. So now what I want to do is I want to factor this trinomial, and of course the two factors are going to be x plus 4 times x plus 4, which we're just going to write as x plus 4 squared. And then we're going to factor the trinomial with variable y. And we're going to get y minus 3 quantity squared. Over on the other side, we have 49. So this right here is the center radius form. So center radius form. And so that feels good. And of course we can just read off the center. It would be at -4 and +3. And the radius we get when we take the square root of 49. So the radius is equal to 7. And so we have our answer. So completing the square, let's go through it one more time. We're going to group the x squared and the x to the first term together, and then we're going to add on a constant to make a perfect square trinomial. And there's a little process to figure out what that constant has to be. Of course, first thing you have to do is you have to start with a leading coefficient of 1, which we have, and then you take the coefficient on x, that's this 8, and take half of it to get 4, and then square that to make 16. So you add 16 to both sides of the equation. The other thing that's worth pointing out here is that when you do the factoring, you already know what the factor is going to be, because that is this number right here. When we took half of 8 and got 4, that's a really important number. It tells us how to complete the factor when we go to factor our trinomial. So it wasn't too hard to factor this one, but in a minute we'll have to factor something more complicated. And then it'll be really nice to know what the factor is supposed to be just by looking right here. Okay, so for part D, now part D is not too complicated. It's mostly the same as part C, as example C. So this would be a great time to pause the video and try a problem for yourself. And then the last one here, part E, is the one that gets a little complicated with some fractions. So we'll go over that one as well. Okay, so what we're going to do here is we're going to complete the square on x and y. We're given, I guess technically it's not general form because it's not set equal to 0. It's set equal to -11, but it's close to general form. So let's just go ahead and write x squared minus 12x. And leave a little space, and then let's write y squared plus 10y, and then let's put in all that's equal to -11. And then when you get some practice at this, then you can complete the square pretty fast in your head. It's just half of -12 is -6, and then square that, and you've got 36. Be sure to add it to both sides. And then to complete the square on y, half of 10 is 5. 5 squared makes 25. So add 25 to both sides. Okay, and then when you factor this thing, I guess what I'd like to do, I really want to emphasize this point here. Half of -12 gets -6, and then -6 squared gets 36. That 36 goes right up here. That's what we have to add to both sides. But the -6 is very useful as well. It tells us just how to write the factor, x minus 6 squared. Is that clear? When we took half of 10, we got 5. So 5 is the number that you need to write out the factor for y. You'll have y plus 5 quantity squared. On the other side, what is that? 61 minus 11 is 50. And so there is the center radius form. And so the center is at +6 and -5. And the radius is the square root of 50, which we should simplify. What 25 is a factor of 50. Square root of 25 is 5, so that comes out. And then we've got 5√2 for our radius. Okay, let's do one more. Just to see the numbers get a little more complicated, but it'll be the same idea. So we have 9x squared plus 9y squared plus 12x minus 18y minus 23 equals 0. So first things first, you know, the leading coefficient has got to be 1 when we complete the square. And so let's just go ahead and take care of that right off the bat. Let's just divide everything by 9. And so we'll get x squared plus y squared plus 12/9 is the same thing as 4/3, right? Reduce your fraction. And then minus 18y over 9 is going to be minus 2y. And then you're going to have minus 23 over 9, all equal to 0. Okay. So now we can group the terms the way we want. So we'll have x squared plus 4/3 x, and then we'll have y squared minus 2y, and then we'll bring the 23/9 to the other side. Okay, so what do we need to add on here to complete the square on x and y? Let's do the hard one first, and then we'll do the, I guess, the easier one. The numbers are a little nicer for y. For x, we need to take half of the coefficient on x. So half of 4/3, which is going to be 2/3. And then we need to square the 2/3 to get 4/9. So we know that we're going to add 4/9 to complete the square. And then when we actually factor that thing, we're going to get x plus 2/3. This 2/3 right here told us exactly how to factor the trinomial. Okay. For y, let's see, half of -2 is -1. Square that and get a +1. So let's just add 1 right there, and then we'll have y minus 1 squared. And then let's be careful here. We need to make sure that we add the 4/9 and the 1 to the other sides as well. When we add all this together on the right, what is this? This is 27 over 9, which is just 3, plus 1 is 4. So all that's equal to 4. And so here is our center radius form. And sure enough, our center is going to be at -2/3, 1. And our radius is going to be 2. Okay, that's a good problem. Look for one like that in the homework. There's one more idea that we need to talk about. I'll save it. One more idea in this section. I'll save it for the next video.